our last chapter where we are going to discuss about polar coordinates. Okay. Previously, in mathematics 1, we always use what we call as a rectangular coordinate or Cartesian coordinate. Another name for it, Cartesian coordinate. Where the Cartesian coordinate always use the system of x and y. But in a polar coordinate here, we are going to use something special where it is a bit different, where here you are going to use what we call as the r and also theta. So polar coordinates, we are going to use r and also theta method, where the value of r represented by the radius of circle, and theta is actually referred to the angle from origin towards the point. Okay, let us try to illustrate it by using graph here. So let's try to see it in another way. Let me use here another part. Okay, let's say here if you have the x and y axis, something like this. You have y, you have x axis, and you have the origin 0. Let's say now we have a circle. Okay, just imagine that this is a circle. Alright, and you have a point somewhere here, where I call this point as point A, where we can write it in general, it will be x and y point. So if we want to get into the point, we can actually tie it into a rope. So this thing, this line, we call it as radius. And if you want to find the distance from here to here, we can see that this is actually your y-axis, and for this part it represents your x-axis. So let me take it out, the triangle that we have there. So we have now the value inside here, we call it as theta, or another name for it is argument. So you have here theta, you have here r, you have here y, and you have here x. So by using a trigonometric function, let's start with sine. Sine theta, by definition, you can say that sine is referred to the opposite divided by the hypotenuse. So the opposite of this angle is y, and your hypotenuse is r. So it will be y over r, or you can simplify it without a fraction. You can bring r to the other side. So you are going to get here r sine theta is equals to y, or y here is equals to r sine theta. This is the first formula that we can get from the illustration. Again, we can go straight away into cos theta. Cos is adjacent divided by hypotenuse, so the adjacent for it is x, and your hypotenuse is always r, so it will be x over r. So you can see that this is r cos theta equals to x. This is another relation that you can get. So let me try to put it in a rectangle or in a box. So this is two important formula that you need to write it down. Another formula that you can obtain here is by using tangent theta, which is tangent theta is equals to opposite divided by adjacent. So which is, it will be y over x, because the opposite of your theta here is y, and the adjacent for it is y x. So here, from here, basically it will help you to find the value of your theta, which is theta can be obtained by using the calculation of tangent inverse y over x, where you can, if you have the value of y and x, you just need to plug in into your calculator and then you get the answer for it. This is another things that you need to write it down. And the last thing here is the formula of circle itself. The formula of circle is x squared plus y squared equals to r squared. So from here you can get the value of r is equals to r squared is equals to x squared plus y squared. So if you bring the power of 2, you can get the value of r will be square root of x squared plus y squared. This is another formula that you can use in our calculation later. So this is our first video, just basic definition for it. We just derive a few formula where we call it, this is the relation of the polar and Cartesian coordinate. So we can get into another video for more examples of it. Okay, so see you.